Good morning, viewer. Welcome to our Glory Globe TV. Here's a most amazing and breaking news for our viewers. Yesterday, the National Oceanic and Atmospheric Administration revealed that despite the active sunspot AR3315 beginning to decay, it could trigger a solar storm on Earth. And just a day later, satellites pick up solar winds that were possibly released from the activity on the sunspot and are likely going to spark a solar storm on Earth tomorrow. June 2nd, the solar storm is not expected to be a major one, but it can still disrupt wireless communications and cause a radio blackout. As per a report spaceweather.com, NOAA forecasters say that minor G1 class geomagnetic storms are possible on June 2nd when a stream of solar wind is expected to hit Earth's magnetic field. There is suspicion that the gaseous materials likely flowing out from a pair of holes in the sun's atmosphere. It is not known whether the sunspot is directly involved in this. Solar winds are not very unlike a CME cloud, which is majorly responsible for solar storms on Earth. The main difference between the two is the intensity of charged particles. Since solar winds are a stream of charged particles released from the upper atmosphere of the sun too, they obtain relatively less amount of charged particles than coronal mass ejections, which are taken from the surface of the sun. However, they are still capable of triggering minor to moderate storms. Such solar storms may not be strong enough to affect mobile networks or damage satellites. They can still cause radio blackouts and disrupt GPS signals, and things can be worsened if these solar winds pick up a CME on their way and combine with it to spark terrifying solar storms. The NASA Solar Dynamics Observatory carries a full suite of instruments to observe the sun and has been doing so since 2010. It uses three very crucial instruments to collect data from various solar activities. They include helioseismic and magnetic imager, which takes high resolution measurements of the longitudinal and vector magnetic field over the entire visible solar disk. Extreme ultraviolet variability experiment, which measures the sun's extreme ultraviolet irradiance, and atmospheric imaging assembly, which provides continuous full disk observation of the solar chromosphere and corona in 7 extreme ultraviolet channels. Ved Nazir, Glory Globe TV, Delhi, India.